basically Iptables is just a firewall, right? So it's just packets come in, packets go out. You can't explain that. Iptables is basically just there to say this packet is allowed, this packet isn't, based on certain rules that you set. For this, like I said, we're just going to go over like the super basic part of Iptables for this, because it's a big program. You can go very, very deep into some of this stuff, and it can get pretty complicated. But for the purpose of this, we just want to do things that most people would use in the huge majority of situations where they're using Iptables. So simple, accept these packets, drop these packets, sort of things. So in Iptables, there's these things called chains, which are basically just a list of rules. By default, you're starting with input, output, and forwarding. And for the most part, those are pretty self-explanatory, right? Input is for any of the rules for packets that are coming into the server. Output is for any packets that are going out of the server. And forwarding is for anything where it's kind of switching interfaces, basically. So just think like a router. So if you've got packets coming in here and it's going to go back out that way, then that's what forwarding would be for. In most servers, you're not going to use that. So by default, I generally set the policy for that to just drop anything that's trying to forward, because you generally don't want your servers trying to forward stuff. You want it inputting and outputting. If you're using it as a router or something, or certain other situations like a proxy or something, that would make sense to use forwarding. But for the most part, I just drop those. The super, kind of the most basic flags that you're going to use are these ones here. So A for append, I for insert, D for delete, P for policy, L for list. The reason there's append and insert is because append, it's always going to add the rule to the bottom of the chain for whatever you're putting in. So if you do a -A for input, the rule that you put is going to go at the bottom of that list. And the order of the rules on any firewall really is extremely important, because when it starts going down the list of rules, like when a packet comes in, it's going to look at the input rules. And when it starts going down that list, the first rule that matches what that packet is, it's going to execute that and then stop. It's going to stop going down the list, right? So if you say something like, if you've got a rule that says port 80, drop them all, always drop port 80, but then later on you say accept packets coming into port 80 if it's coming from this address. That rule will never be processed because the rule above it says to always drop port 80. Does that make sense? So the order of the rules is extremely important. Append will always put it at the bottom of that list, and insert will put it wherever you want. So if you say -I and then input and then say 5, it'll put that as the 5th rule in the list, right? So you can kind of put the rules specifically where you want them. Delete, obviously it deletes a rule. P is for the default policy, which is generally going to be accept, drop, or reject. And the difference between drop and reject is that drop just drops the packet, right? And reject actually sends a response that says, hey, we dropped this packet. Personally, I always use drop, because if something's hitting my firewall and I'm not allowing it in, there's probably a reason for that. So I don't really want to send information back to whoever's trying to hit my firewall in a weird way. So I'm just going to ignore it and drop the packet and not let them know I'm not letting this in. And then line numbers is extremely important, especially if you've got huge lists of rules. Because if you want to put a rule in a particular place, or if you want to delete a rule, knowing which line number that is really, really important. So when you're writing rules, there's some really common flags that you're going to use. -S is for source. So that's basically saying, where is this packet coming from? Like what IP address, what IP range, what am I allowing or what am I dropping as far as that. D is for destination, so where the packets are going to, and that can be input or output, right? So if you've got, for instance, multiple interfaces on your machine, those different interfaces will have different IP addresses. you might want packets on certain protocols to be allowed to come in on this interface, but not this one. That makes sense? So D is for destination, P is for port, which is generally, it's referring to TCP, UDP, ICMP, so that at that layer. And then D port is where you're listing your higher protocol, your specific one, so like port 80, port 22, things like that. -J, I honestly don't know why it's called jump, but that's where you accept the packets, drop the packets, or reject the packets at that point. So -J and then accept. So I've got couple of examples right here.
I do know the reason for that.
Okay.
The accept and drop are other chains that it can, so input and output. You can also jump to something that will process it further, then jump to accept.
Right, yeah, okay, that makes sense. So this is a couple of examples here. When you're entering Iptables rules, you're always starting with just the word Iptables. So in this example, it's showing -I and then input. So we're inserting a rule into the input chain, and we're putting it in the second spot. So the second line, right? We're saying the protocol, we're doing TCP, and the destination port is 22, so SSH. And then we're saying the -S, so when it comes from this IP address, we're going to accept that packet. Does that make sense? So it's looking at it without knowing what the flags are, it can be kind of weird, and you might not understand what it is. But once you know like those handful of flags, because like a huge majority of rules that I use are always just kind of this stuff, right? So these are extremely common flags that people generally use. It's not that often that you go outside of this. So entering rules like this is pretty common, and you're basically just saying where you want the rule to go, what kind of protocol it is, where it's coming from, and then what to do with the packet, right? So same with this one. We're just saying we're going to append a rule in the output chain. We're basically saying anything that's port 80, so HTTP, we're going to drop it. So basically this server isn't allowed to reach out on port 80 is effectively what that rule is saying. I don't know what I did there. Yeah, so like I was saying before, the order of the rules does matter. And it's for a couple of reasons. One is because, like I said, if you put a more specific rule below a more general rule, that more specific one is never going to be seen, because that general rule is going to hit those higher packets and just drop everything before, or accept it, whatever the rule says, before it gets to those bottom ones. But also another reason for that is actually performance. If you have a server that's receiving a huge number of packets all the time, and you've got 100 rules on your input list, and the bottom one is processing 95% of the packets, every time a packet comes in, it's processing through every single one of those rules to find a match before it gets to the bottom of that list and then says, oh, do that. So in any situation where you can, the rules that are being used most often, you want to move higher in the list so that it's processing a lot less. And then generally when you save your Iptables, it saves to this file. So that's just super helpful to know.
Now, I remember working with something, it didn't persist. Like when you're entering some rules, like next time you're rebooted, they did not persist those rules.
Yeah, so rules by default aren't going to persist. You have to tell it to save. The easiest way to do that really is just say service Iptables save.
I remember that, like, well, I made all this work, rebooted, and it's all gone.
Right. Yeah, and that will happen if you don't save them, because when you put the rules into Iptables, it puts it into the running config, but it doesn't save them. So if you reboot the server or even just reboot Iptables, all the rules that you put in are going to go away unless you've put them into this file. I started up a VM just to kind of show just what Iptables rules look like when you just list them out, just so that we can show that really easily. So this is saying to allow any rules on any related or established connections. So for instance, there are certain protocols that might operate on one port and then move to a different port for different reasons, or just stuff like that.
Long running things like SSH, those
Right.
connection is established.
Right. So you want to be able to keep those open in situations like that. And this rule is extremely important for that, because a lot of people forget those sorts of rules. And if you have so for instance, if you're sending out packets and you're allowing anything to go out, but you're not allowing things to come back in, and you don't have a rule set up like this, those packets might not come back in, depending on how your other rules are set up. So having a rule that allows establishing related connections to communicate is pretty important. This one's just allowing IP or ICMP, so like ping and traceroute, stuff like this. This one is allowing everything on the loopback. It's not showing that right now because this starts looking ugly when we go verbose, but it's just allowing anything on the loopback address to communicate internally. And then it's allowing SSH. So this is allowing SSH connections in, and then this is rejecting anything else. So it's saying SSH is allowed, but we're not allowing anything else to come in. And we can change that to drop. Like I said, I prefer and then we can delete, what is that, rule 5. And then if we list that again, now we've got a drop instead of a reject. So at that point, it'll just drop any packets that are trying to come in that don't meet the previous rules. And then on this, we're allowing any output connection and rejecting anything on forwarding. But again, we can set a policy on that to just we're not jumping. So now the default policy on this is to drop rather than to accept connections. It's still going to reject in this situation because it's going to start going through the list of rules, and then the default policy is only going to matter in situations where the packets don't meet any of the rules in the list. Does that make sense?
So you're saying that last rule that you added to the input chain, you could replace that drop with a policy change there too?
Correct. So instead of doing this, I can P for policy input and then say drop. This does exactly the same thing as this, having that there. But some admins prefer to have the rule at the bottom of the list just because it's something that they can more easily see rather than looking for a default policy. They just like seeing that any drop. It's kind of a comfort thing, I think, to know that's there.
More explicit.
Right. They do the same thing. I often do both. So I'll put the policy and the rule just in case someone comes along and like removes the rule for some reason, because that also is a thing that happens. But so for the most part, this is pretty straightforward and simple stuff with IP tables. Like I said, these sorts of flags and these rules are what you're going to use a huge majority of the time. So just kind of memorizing that short list of rules will do a huge majority of what you'll ever need with IP tables. Does anyone have any questions on clarification stuff or anything?
I got a story. If you remember the red versus blue competition we did at Hack West.
Hack West and B-Sides and yeah.
We were the other team was hoping they had firewalls external, but we ran IP tables and locked down our stuff really quick.
Yeah.
Yeah, in a competition.
We were on the same team, right? Yeah.
We were on the same team.
Yeah, and we actually had a guy that was a firewall guy. He was just
Andronicus.
his job was just handle IP tables on all the servers. Yeah.
But he probably basically won the competition before the two.
Yeah, because he locked that stuff down quick. Yeah. So the difference between reject and drop is when a rule comes in, or if a packet comes in and it meets a rule that says drop this, it's just going to drop the packet and pretend it never happened. It's just going to say, this doesn't belong here, I'm going to get rid of it. Reject does that, but then it will also send a message back to the source and say, hey, we rejected this packet, right? So generally I prefer drop rather than reject, because if someone's throwing weird stuff at my firewall that I don't want coming in, I don't like to send information back to them. And I just don't like giving information where I don't need to give it. So I generally tend to not use reject. On all my servers, if I'm setting up a server, I'm replacing any rejects with drops. Sure, absolutely. And firewalls can be a little bit annoying depending on how they're configured when it comes to troubleshooting, because a lot of admins like blocking things like ICMP, so your server will never respond to a ping, things like that. But yeah, how you configure your firewall will certainly affect how you do your troubleshooting. Absolutely. Are you talking about here? So here, yeah. So like for instance with this here, like this is saying the destination port is SSH, so which is 22. So like we can also do a -n and we can see a 22 instead of an SSH here. And that's, yeah, that's the only one really in this list that's showing any port numbers. But yeah, when you're setting the rules, you can say the rule, the protocol, so like SSH, HTTP, whatever, or you can give the port number. I generally work with port numbers.
When you've been in it long enough to start memorizing both.
You don't even notice the difference.
Right, yeah, so it's, yeah, but when you're listing them out, you can use a -n, and that'll show you the numbers rather than the names of things. And the -v will also give you a verbose, so you can see like which interface it's affecting and stuff like that.
The -n also, if you look at the source and destination there, they're IP addresses instead of anywhere.
Right.
Now, one reason, say in a desktop scenario, reject, denying all outbound packets would be painful.
It would,
Let's say
but
that
in a server, it's often necessary.
Is usually, yeah, your server, you would default deny outbound and only allow that what you want.
Right.
Because you're trying to protect yourself from, let's say, reverse shells or things
Or
like that.
exfiltration.
Yeah.
You know, you don't want your server being able to communicate anywhere in the world on any protocol, because if an attacker gets into your network, they might be using that server as a staging server to exfiltrate all your data, right? So if you're blocking a lot of that outbound data, you're making it more difficult for them to do that, right? And that's kind of the whole point of security, right? Just make things as hard as you can for the attackers.